Dear participants, I welcome you all and today's resource person, Dr. Amrita Agrawal Madam, on the virtual platform of the International Workshop on Digital Image Processing. First of all, I regret the inconvenience caused due to the cancellation of yesterday's session in an emergency. I am sure and I assure you Dr. Amrita Agrawal ma'am covered the topic which is missed yesterday, and we are going to enjoy one more day with Dr. Amrita Agrawal. Hence, I am sure today and tomorrow she will cover all the three topics. Today Dr. Amrita Agrawal ma'am is going to deliver a talk on atmospheric errors and correction, and if time permits, she will also focus on geometric errors and corrections. I request Dr. Amrita Agrawal ma'am kindly proceed ahead.
Yes. So in the last lecture, we focused upon the errors which were caused due to pixels which could not be captured by the sensor. They were the system errors, they were the sensor errors. And in that we saw four types of errors which were random bad pixels, line or column dropouts, line start problems, and end line striping, in which we saw that either one or two random pixels or an entire line or column or an entire imagery is distorted completely, where you cannot see the missing values, where you cannot see the pixel values. We also saw what is a pixel, what is a pixel value, how does it come, and what is the reflectance behind each pixel, what is a reflectance value, for which we also understood the concept of electromagnetic spectrum, that is the EMR. Now today we are going to look at atmospheric errors and corrections. Yes, and we will also look at how to remove them. The first, so what is an atmospheric error in the first place? It is any disturbance in the atmosphere which is captured during the capturing of the imagery, and it makes the image hazy, it makes the image unclear. Now, yesterday, when last lecture, when I explained what happens to the light falling on the earth, I said that when the light starts from sun and it comes on the earth, three processes take place. The first is absorption, the second is scattering, and the third is reflectance. If you see in a particular order, the first thing that happens to the light is it interacts with the atmosphere. Now, as soon as it interacts with the atmosphere, what we see is scattering. Now, scattering is nothing but because of the size of the different particles, the different sizes of the various particles in the atmosphere, the light scatters. Now, when this light is scattering, it helps us to get daylight on the earth. But this light cannot be used for reflectance as it does not reach the ground. However, it causes haziness because when there is more light, you cannot absorb, you cannot capture the imagery. For example, whenever you're taking a photo, if there is more light or if there is some reflection of the light, in your photo you can always see a white spot, which will be because the light is either falling on that area or it is not correct. So if you use a flash also, the image will be incorrect. Yes, you will not be able to see what is in the photo. It used to happen in the olden times when the cameras were not very advanced. So even today when you see the pictures, you will not be able to see them clearly because of the incorrect light. Yes. The second thing is absorption. Now you are planning to take a picture or an imagery of an object clearly. But if the object is dark in color or if it is in a dark area, it will absorb maximum light. Now when it is absorbing maximum light, it will reflect less, and when it is reflecting less, the number, that is the reflectance value that will be captured by the sensor, will be less. Now if that is less, you will not be able to see the object correctly in the imagery. The all this results in what? Atmospheric error, that is problems in the imagery due to problems with the processes of the atmosphere. Now they hamper the clarity, they hamper the visibility of the imagery, due to which what happens is you cannot identify the objects in the imagery and you cannot interpret them. For example, you can see the imagery in front of you. It looks like a snow covered area with some vegetation or agriculture, but because of the haze in between, which mostly looks like a cloud, it is difficult for us to understand the objects there. It is difficult for us to understand a clear view of that area. You may say that it is cloud cover, it might look like fog or smog also, but it is something which is due to atmospheric disturbance. Now let me bring to your notice that atmospheric difference error could be because of weather conditions also. Like in the other lecture I answered a query wherein I said that February is the best month to capture an imagery. That is purely because of the clearest sky available in the country of India, and here you have minimum cloud cover and therefore you can have maximum visibility. Plus, if you want to do vegetation or agriculture analysis, if you want to do soil analysis, you want to do moisture analysis, like whatever natural phenomena are best viewed in the month of February in a satellite imagery. However, due to the problems like pollution, due to the problems like inappropriate technology and inappropriate knowledge of calibration, what happens sometimes even in the month of February, you will not be able to capture a clear image. Now when that happens, you have to clear the haze. How do you clear the haze? So let us understand the three types of errors first, and the ways to remove them. The first one is absolute and relative corrections. So in absolute corrections, what do? We use atmospheric conditions and illumination. Now what do you mean by illumination? Illumination means, can anyone tell me? Yes, what do you mean by illumination?
Madam, illumination means energy emitted from this object.
Energy emitted from the object? No, that is reflectance.
And glowing?
Illumination simply means, yes,
Is it
sorry,
glowing?
yeah, kind of that. So any object that emits light, now here it is not, it is like a bulb or any object which will help you with light, like when you're doing shooting or when you are, if you have seen a shooting or a photo studio, do they rely on natural light? No, they have tube lights, they have the yellow bulbs, they have extra objects that illuminate light, that emit light. It does not mean that light falls on an object and whatever it gives back is illumination. No, it is simply how much light is present in that area, because ultimately this is photogrammetry. Photogrammetry means it is the art of capturing good photos. So in the art of capturing photos, light plays the most crucial part. Yes or no? Because if the light is incorrect, the photo will be incorrect. So now if you, since we already know that there will be certain errors, and if you want to avoid the errors, you must take all the precautionary measures. The first precautionary measure is to remove the absolute errors by using absolute correction. In that, what do? We see the atmospheric condition. Now, suppose if I want to take a picture of Mumbai during July, what do you think? Will I have enough light? No. Will I have enough clear sky? No. Will I have a clear view of the streets? No. Because the monsoon is already approached in Mumbai during the month of July. due to which there are many clouds in the sky. Now, because there are many clouds in the sky, often we have experienced a darker Mumbai or any area in the Konkan, for that example. Any area in Konkan receives monsoon during the same time. In fact, Ratnagiri, Raigad, Sindhudurg areas receive more rainfall than Mumbai. So during the monsoon season, when the rainfall is quite heavy, neither do we have a clear street, that is because of the water, nor do we have a clear sky, that is because of the dense cloud cover. And because there is a dense cloud cover, the area is also dark. You do not receive enough light. Yes. Now, so first we see the atmospheric condition. What is the atmospheric condition? And the illumination. The illumination is, suppose if it is snow covered, or sorry, if it is cloud covered, it is totally, it's going to be very dark. Even during the daytime, the sun will be hit by the clouds and there will be dark, so automatically the pictures will not come out well, the imageries will not come out well. And along with these two factors, we also look at the viewing geometries at the time of image acquisition. Now, what do you mean by viewing geometries? It basically means the angle at which the imagery will be captured. So, for example, if the, now we all know the geometry, the geography of Maharashtra. There is Western Ghats, and on the windward side, and there is a leeward side. What comes on the windward side and what comes on the leeward side? Can you tell me, please? Windward side and leeward side of the Western Ghats. I'm just giving an example, but you should be able to understand the example.
Madam, western coast of the Sahyadri, Western Ghat is western coast of Western Ghat is the windward side, and
Very
eastern
good.
coast is leeward side, rain shadow area.
So, for example, Pune and all the other districts that fall in that belt will come under the leeward side. Now, suppose if I want to capture an imagery of an area on the leeward side of Western Ghats, what do you think should be the angle of my sensor? Should it be on the windward side of the Western Ghats or should it be on the leeward side of the Western Ghats? If I want to take an imagery of Pune, for example, should the sensor be facing towards leeward side or the windward side of the Western Ghats? Let me describe the example that I'm trying to quote here. Now see, this is Western Ghats, for example. Yes, and here you have the Pune district. Yes, so it is. Now I'm asking, if you have the sensor, that is which is placed on the satellite, where should the angle of the sensor be? Should the sensor be here and trying to capture a picture of Pune from here, or should the sensor be here? That is, either it should be in position A or should it be in position B? Please tell me.
B. B.
Why do you say B?
Uh, because of the angle, maybe. Because of the angle.
Yeah, that's what I'm trying to tell you. That see, whenever we are trying to, viewing geometry means geometrical analysis or geometrical tools that will help you to view the picture to the best. So we have to make sure the area that we are trying to capture, we must know the surroundings of that area, we must know the area's physiography or at least basic physical geography, so that we know from which angle should I be able to take the imagery. Now when I say we are taking the imagery, does not mean that we are actually controlling the sensor. No, when we order the imagery, okay, we have to be very clear on the part of the angle from which it should be taken. Now, generally, we do not have to give all the specifications. We only have to mention the area. But suppose if you are employed in a position where you have to control the imagery, that is maybe you are employed in ISRO or Bhuvan or somewhere like this, then you will command, you will control the sensor, the satellite, and the angle. Therefore, if you want the best of the view of the imagery, the angle has to be perfect. Now, this is very true in the case of aerial photographs. We know that aerial photographs are of two types, vertical and oblique, correct? Vertical means taken right from top, and oblique means taken from a side angle. In that also you have two more types. Now, similarly, whenever you're taking a satellite imagery, if you want to avoid the in clarity, that is, if you want to have the most clear picture, few things you have to keep in mind. Like I said, the first one was the weather conditions, second is the light, the angle of the light, and the third is the angle from which the sensor will take the imagery. Now, when you try to understand, photogrammetry in depth, you will be able to relate it to even the small pictures that you take from a mobile. So whenever you are in a birthday party or something, you take photographs, correct? And you will say, you will tell the group, no, don't take from here, you take from there. See, the light should be proper, see whether there should be clarity, there should not be. In birthday parties also have fog machines, etc. So just try to correlate with your normal day photography. The same principles are applied in the remote sensing technology also. Now, these three conditions we keep in mind at the time of acquiring the image, that is image acquisition. Now, why do we keep these things in mind? So that we can understand. See, there are bands in EMR. Kindly mute yourself, please. There are bands in EMR, and the two important bands through which we can take satellite imagery is one is the visible band and one is the infrared band. Nowadays, however, micro wave radiation imageries are also coming in focus because of their capacity to be able to detect heat. But the most common, because colorful imageries will produce the best interpretation of the imageries, the most common is the visible band followed by the infrared band. So each band has its specifications, and before we want to know the best clear imagery product, we must calculate which band will be affected by which factor of the current atmospheric conditions, and accordingly only we can use that particular band or that particular imagery for our analysis. Not all bands are suitable for all types of objects. Each band has its own specification. That is, whenever we go to, suppose you learn about the bands in depth, you will be able to understand which band suits which type of object on the surface or even in the water. Okay, now all these things when kept in mind, we can adjust all the factors and see that our imagery turns out to be the best. Now, absolute atmospheric correction needs access to. So if whenever you're trying to understand the errors that are possible and you want to remove the absolute errors, you must have all the following information with you. So if you plan to take an imagery, you should see that you have all these databases ready with you. The first one is information on atmospheric conditions in the area, like I gave you the example of Kokand. Then now there is something called as relative transfer code. Now what is this relative transfer code? Has anyone heard of it before? Okay. So see, the definition is written here. It calculates the radiative transfer of electromagnetic radiation through a planetary atmosphere. What does it basically means? You have electromagnetic radiation, that is the light in general sense that we're talking about. So each object on the surface of the earth has a has a set value of reflectance, like I said last time also, which is called spectral signature. Now this spectral signature should be decodable by the software that you're using. It should be able to understand that if this is the spectral signature, this may be the object. Okay, at least you get a clear reference point. Okay, and if there are some changes, you can always run classification and find out the discrepancy in the software's detection. But The radiative transfer code is a tool in the remote sensing software which helps us to understand the reflectance values that are captured in the pixels to the best of the possibility. Means whatever the codes it has received, whatever the values it has received, it will automatically enhance them and be able to. And still, if there is unclarity or if still the image has haziness, then we will go ahead to remove it. And the third thing we need is the software, the correct software which will help us in the implementation of the algorithms in a programming environment. Now I would like to bring to your notice that remote sensing and GIS are two different technologies. Whatever you want to do with raster data, that is the data made up of pixels, can be done in a GIS platform also. But if you are necessarily working with advanced satellite imageries and advanced raster analysis, only remote sensing softwares are suggested. The best is Erdas Imagine. But like Sir pointed out the other day, it is a very costly software you cannot purchase. You can go with Saga. You can also go with Python programming. That is Python GIS, in which you only run the codes and you get the outputs from the imageries, both raster data and vector data, for which you will have to learn Python programming, you will have to learn JavaScript, you will have to learn even SQL, and then only you can do the programming. So all this that I'm trying to explain you since the last lecture, the errors and the corrections, they can be done on two ends. One is on the programming end and one is on the user end. That is, user end will be through software and programming end will be you are doing it through a language and not a software proper. Yes. So first is information about the atmosphere, second is information on the electromagnetic radiation and its convertibility by the software. You should also be able to understand what the software is trying to give you as an output. And the last one is the correct software which will help you to do all these processes in a faster and in a better way. Now after absolute errors, let us understand relative atmospheric errors. Now these are simply atmospheric condition errors due to atmospheric conditions. So what does it try to say? That the conditions on the actual ground and the conditions which are visible in the imagery due to disturbances in the sky are different. Okay, so on the ground there may be, for example, a lot of vegetation, but because of the disturbance in the atmosphere we are not able to capture that vegetation, so you are not able to understand how much the area would be under vegetation. So relative means what is the condition on the ground and what is actually visible in the image. Now that is caused because of the disturbance in the atmosphere again. Now how can you remove small disturbances? The earlier one which I discussed is absolute, is it's going to be a larger error, that is maybe the entire imagery is covered by haze or maybe a larger part is covered by haze, but in relative only a small part is covered by haze, which you can easily remove by either ground truthing or by averaging method. That is, maybe you will try to understand the surrounding features. So the keys of image interpretation will help you to understand the imagery better. Yes. So what do you mean by linear relation here? Basically means, suppose if one part of the imagery is covered by haze, but around that you have water. So obviously that could also be water. If a patch of vegetation is covered by haze and the rest of it is vegetation, then that also has to be vegetation. So these are small errors which you can correlate with other objects in the imagery and then try to find out which that object is which is not clear in the imagery. Now, the second error here is the hazing part. That is, the imagery is not clear like you can see here. This is actually haze that I'm talking about over here. So this haziness is very common because everywhere on the planet there will be some or the other atmospheric phenomena going on. There is some or the other pollutant in the atmosphere and which is going to cause a hindrance in the overall image capturing. So it is very common and it may be due to water vapor, ice, fog, sand, dust, smoke or other particles in the atmosphere. So basically it is entirely due to the pollution that is present in the atmosphere, and now it's going to be, it is become worse because of the artificial chemicals also which are present, and they do not want to come down. So sometimes in the winter seasons what happens is, what you see is not fog, is also smog. Smog basically is polluted fog. It does not only have water vapor and dust particles, but it also has chemical traces, which makes the visibility even poor. So if there is smog on an area and you try to capture the imagery, you can definitely not capture, because artificial elements like the chemical gases, etc., will only absorb light. They will not allow light to pass through them and reach the ground, due to which you will not be able to capture good imageries. But this type of haziness can be removed because there is something called as haze thickness map. Now this haze thickness map is a plugin in the software which calculates how much of the pixels are hazed, and it tries to remove that layer entirely from the image, just like how you clean a vessel. Similarly, this haze thickness map calculates where the haze is thick and where it is more and where it is less, etc., and it tries to remove the layer of haze entirely from the image. Now once that is done, you are able to then see a clearer image. So see, can you see, there are various types of hazes. So in one imagery, it is covered entirely, but you can see something below it. In this, and it totally looks like cloud. So if this is water vapor which has formed cloud, okay, it will be seen as cloud. Now, in some areas, you can even understand what is there below the haze, but in most of the areas, it is difficult to understand where you have to remove. So what does it do? It gives you where the thickness is more and where the thickness is less, and accordingly you can remove the entire layer and try to rectify the imagery to make it better. Yes, so what you see, the first image, the entire image has similar haze. You can see that the image is a little blur, it is not very clear, and the light falling on the image is also not very high. Why? Because the entire sky must be uniformly covered, or the entire area must be having the same type of pollution or hindrance over it, due to which the entire area is looking same. But still you can interpret the objects. There will not be much difficulty in interpreting. So here the thickness is less. Okay. In the second image you see moderately thick haze. Now, in this, only over a patch you will find a very thick haze. That is, it can be seen evidently that there's something like a cloud or a water vapor layer or some chemicals, or it may also look like smoke in the imagery. So this is a little thicker haze, but it is only concentrated in one area. So other areas के help से you can do the association and try to understand what this particular object may be on which it is covered. However, it is still quite visible. In the third one, it is moderately thin haze. Now, in moderately thin haze, you are able to see everything, but it looks very thin. It looks like, some smoke that is maybe coming out from an area and is getting collected. Over here, not all objects are clear because of the white patch that you can see on the imagery. It looks more like a blot of light than blot of smoke or haze. And in the last one, it is called thick structured haze. It is like, it is situated, it looks like small circles or it has a shape, okay, and it is quite thick, due to which you can actually not even see what is beneath the haze. Now in the picture B, you can still see something even through the haze, but in picture D you cannot see what is below the haze. However, since it is, in this example, it is concentrated only in a small area. With the help of other areas, you can identify what the object is. But suppose if the object is entirely hidden due to haze, then in that case, you have to remove the haze with the help of the model. Now, the third error and correction is that, see, when you do land use land cover analysis, when you do analysis of changes in the soil, when you do water level analysis, hydrological analysis, etc. Then we often have to compare between years, between two dates, and even sometimes we compare between two areas. Like for example, Google Earth. On that you have a tool like historical imagery. So there if you set an update of the past and you take the latest imagery, it is often not necessary that you will be able to get a clear imagery for both the years of the same area. Some year there may be some disturbance, the other year the image may be clear. But if there is disturbance even in one imagery, it is difficult for you to make a comparative analysis because you cannot identify the objects correctly. It may so happen that the area where there is haze, the area where there is cloud cover, there is disturbance, that area has only changed in a few years. And you want to desperately know what was there before and what is there now. So, in such conditions, what do? Either you can use the de-hazing method, or the second is you use the method of normalization. So, between the pixel values, you find the average. Yes, and then try to give the average value to the pixels which are not visible, and try to understand what is the object over there which is not understandable or visible in one of the years which is under study. For example, this image that you see in front of you, it is of the same area and it is of two different years. So what is done? First de-hazing is done. Then also certain objects were not clear. Hence averaging method is used. So now even if the images look little different, you can still say what has changed in the one image to the other image. That is what change is has happened in the area between the 2 years or the two dates that you are looking at. Now it will often happen when you are working with a gap of 10 to 20 years, because now climate change is taking place. So when climate change is taking place, if you have an area which did not receive rainfall in February earlier, but it is now receiving rainfall in February. So, what will happen? Today's picture will have cloud cover. You will not be able to compare, but you cannot even go back and take an imagery of the other period because that it is gone forever. So, what you will have to do? You will have to make corrections in the imagery that is of the today's time, and then you can do a comparative study of both the imageries for the two different years of the same area. This process is called normalization. It minimizes the difference between two imageries caused by inequalities. Inequalities due to atmospheric problems, inequalities due to sensor problems, whatever the problems may be. And then it does not change the reflectance, but it will minimize the error, it will minimize the disturbance. So if there was water before and now also if there is water, you will be able to identify it as water only, but maybe to a limited extent. But once normalization is done, you can identify it to the maximum extent. Yes. Any query in atmospheric errors and corrections? Yes, are there any queries in atmospheric errors and corrections so far?
Dear participants, Dr. Amrita Agrawal ma'am has covered the topic of atmospheric errors and its corrections. In this regard, if you are interested to ask some few questions or regarding your research topic, if you have any questions, please feel free to talk with Dr. Amrita ma'am.